So this is going to be the process in which I set up my data-driven CV, a resume that is constantly updated based on new inputted data through an automated pipeline. Input new data, click compile, your resume is now updated. And just like with anything with code, it's easier to abstract a lot of this away, have a simple interface to add new data, and then have all the formatting and generation of the structure and the document itself completely up to software. So all of the resources for this particular talk, including a sample empty version of my exact copy of my resume, can be found on GitHub here. And yeah. So following along with this, if you were to do this on yourself, there are some certain dependencies. You will need RStudio, the IDE, the packages that you will gain by running these commands right here in the R command line. And the hyperlink to the template repository will also be provided. The technologies used in here are LaTeX, R, YAML, Markdown, and not really a CSV file, but comma-separated values. And we'll talk about a little bit what those are. So for anybody who's unfamiliar, YAML is a simplified, not markup language, but it's a kind of like JSON, a data interchange format, but there's no braces, white space matters like Python, and you basically deal with key value pairs with value, comma, and then, or keys, comma, values. And you can have a couple other things. It's a very simple language, but R and RMarkdown use it for a lot of meta control options. So a lot of the settings we're going to be dealing with are set via YAML, and then the content is in the body of the documents. We will take advantage of template literals. This is usually something you'll see in a lot of different languages. C has this, C++, JavaScript, and template literal is actually a term I think I got from when learning JavaScript, where you have variables out in the whatever scope you're working in, and then the strings have a particular tag or syntax like curly braces within the middle of a string, and then it easily will just drop in the value of a variable straight into the middle of a string on the fly. We'll be using row-wise data frames. You'll see what that is in a minute. It sounds like a complex thing. It's not. It's basically CSV, but actually visually laid out like a table. And very basic LaTeX, if anything, usually just for page breaks. Yeah, so we'll just jump right in and get started. My CV is on my GitHub because it's a perfect place to put it because it's driven by code. Everything in the CV stems from the RMarkdown document. So the primary things that are important are this RMarkdown document and then the data actually in the R folder. So the RMarkdown document itself, this is actually a horrible view. I'll go to RStudio. The RMarkdown document will look like this. So we have up here, this is a common syntax among pretty much any Markdown documents that utilize front matter. So things that are being produced by a static site generator like Jekyll, RMarkdown, normal Markdown. You can actually display YAML like this on your GitHub Markdown documents. It'll display like a little table at the top of the document. And then YAML is useful for lots of other things like GitHub Actions, automated pipelines, and Azure DevOps, and a variety of other uses. It's a very simple language and format to learn, and there's not really too much to it. So there's some basic key value pairs you can have, your name, some addresses, and some of this stuff, the names are weird compared to what you expect them to be. So that's why I provide a sample of like my resume so you can see where everything is kind of mapped to. But all of these little details in the front matter provide a bulk of the formatting and meta control options like head color. This is basically the color theme of your entire CV, which mine looks like this. So I have this red color throughout. All these different pieces of red are all based off of that single hex code value here. So all of this stuff you see on the front, let me just make this half screen for legibility there. So all the stuff up here in this top of the document, you'll see represented in the YAML. My name, what classification I am, where I work, and all that stuff is laid out here at the top. So this is all basically everything up here. So after we get through that, you're going to be looking at the actual body of the document and everything that goes into this. So in the RMarkdown documents, there's this setup chunk. It looks like fenced code areas in Markdown documents, but there's only a slight difference. You have curly braces around the language that's being defined. And then because of the way that RMarkdown treats code fences, you can actually use a bunch of different types of control options and other exciting things with fenced code chunks. But this one is usually the standard one, setup. This was where you run like a bunch of like meta stuff, load packages, set things up for the environment later on. And all I'm doing in here is requiring this xfun package and then making a kind of like a vector or just a grouping of values, those values being the names of packages, what I have suggested you install to run this, which you'll need. These are dependencies. And it's basically running this code chunk. Xfun is just like a bootstrapper, so I can say, hey, here's an array of packages, load those things. And that's it. It'll load it if you have it on your system, and if you don't, it will install it for you. So it's basically a bootstrapper. And then I'm sourcing the actual data. So we need to add the data to the environment to work with, and that's all we're doing in the setup. So once we load the data, what does the data look like? What exactly are we loading? So if I open up data, this is how it all works. This is the secret sauce. There is a package called Tribble in R, and Tribble stands for a tibble, which is another funny name. Don't get me started on the R package naming conventions. It's kind of a wild, wild west situation. So anybody can name it anything they want, which is why you get some really kind of goofy stuff. Data frames. Data frames are basically tabular data. So if you've done anything with SQL, a table is a table. If you've screwed around in Excel and you've seen a range of values treated as a table, that's a table. If you've done anything with Python and pandas, same thing. They're dealing with data frames, or basically tables, and how code is going to treat the representation of the data structure of a table. Data frame, rows and columns. So a tibble is just a data frame in R, because R can say as data.frame, that creates a data frame data structure that you can work with and do things with. Tibble is like data frame plus plus. There's a bunch of extra value added, quality of life pieces to it, and it adds some more functionality. So that's a tibble. A tribble is for the R, a row-wise tibble. So the only thing that means is normally you would say, here's my column header. So I could say column, and then you might have a list of all of the values like in the CSV, but kind of still reverse, where you'd have like all the values after a column. So you would just do it like this. So each column is on its own line. Well, that doesn't read very well, especially when now you have 50 values here, and then you go to your next column variable, and then you have to figure out where something doesn't line up. Kind of messy. So the row-wise tibble is saying, here's the first value, here's the column, area, and the first value is for area until you hit a comma. That's it. So it's basically a CSV, but you can actually paste this in like this and feed this into the data structure exactly like this. So in this case, this is your data. It's just row-wise tibbles or data frames or tables. So that was probably more than anybody wanted to know about that, but that is basically what we're working with, is just a bunch of data in this format, comma separated values with headers and values. And so each of these is being named, and it's inside of the function Tribble. So once we load all those things in, I can actually source this right now. Oh, I need to load the packages first, don't I? So I'm going to source that data. Now we have all of this data in the environment. So let's say certifications. Certifications was its own Tribble, and so I have area, accomplishment, blah, 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 and all that data in there. So now, if I open that up and to view it, we can see that each of these is a column header, data type, values, and all of that data is in there. And it's the same for each of those. It's basically just repeating the same thing, but for different areas of concern, such as certifications, skills, honors, and you can make up as many of these as you want. So this is how you're going to feed into each section of the resume. I decided I wanted a section for projects, a section for certifications. So you can make up whatever sections you want, but this is how you feed the data in. So now once we have our data in and loaded, this is where the actual main package of this resume comes in handy. We're using the vitae package, or like curriculum vitae, CV, resume. Now the vitae package really, in essence, just has a few different helper functions inside of these actual detailed entries function calls, the values we're assigning variables to. All of this is really just a wrapper for using a LaTeX template. What is LaTeX? LaTeX, without getting in the weeds because it's completely irrelevant to know so far with all this, is a typesetting language with absolute crazy granularity. And it is pretty much the industry standard way that scientists, academics, and anybody who writes journals, research papers, etc., will produce work, because you have exact control over every single bit of formatting and typesetting, which is required when you're trying to make something formatted to meet the specifications of a journal. LaTeX code example, so you guys can see what this craziness and insanity looks like. So if you've done anything ever with strings and escaping characters inside of code, you'll know that we use backslashes to escape a lot of different things, like \n for new lines or special protected characters. LaTeX kind of flips that on its head, where basically every command is started and runs by using a backslash. So it's really disconcerting when you first start playing around with it. But yes, that's all you really need to know about LaTeX. So we're using a LaTeX template and then kind of using that as the engine, the skeleton, to feed in our data and then have it structured based off of the way that template is structured and set up. So what do we have here? Now with what I'm doing here, inside of each of these sections, I need to have it inside of a code fence. You can name it or you don't have to name it, but I decided to name it like this because this helps me find it in the little pane here on RStudio. But under each H1 header section in my RMarkdown document, because the different levels of headers matter when it renders, I have the section, I name it as the code chunk. Now I'm taking our data. So the work data, again, was a tribble, bunch of comma separated values in a row-wise tibble. All this mess. Why does this look all kinds of crazy and duplicated? I'll show you why in a second. So we take that, and then using a particular R operator, this is something I've only ever seen in the R language that makes it really nice and fun to work with. It's called the pipe. Now, the command line has its own pipe, and it's sort of similar, but the reason why R's is different is that R takes the pipe, and it takes whatever's values on the left and puts it into the right. That's exactly how the pipe works on the command line. But instead, R does this with data frames. So I can say, hey, take the data frame or the tribble, tibble, same sort of concept, take what's on the left, put it into the right. And so all of these functions for their first argument, which would normally be here, and then a comma, and then all of this stuff, it's just assumed when you pipe in something that that is the first argument. So almost all of these functions, detailed entries, you can see right here, data. It's assuming, and it knows that that's being inserted there. So almost all these arguments that play nice with the pipe, their first argument is going to be data. So what are we doing with this? Now you can see over here in the actual viewer for the data I have, we have variables, title, unit, month, year, where, detail. These are the actual parameters in the function where I'm feeding the columns from our data frame into those variables. So what is the width going to be? It's going to be the title variable from the work data frame. So basically that entire column of values, that's going to go there. And that's all we're doing here. We're basically saying this thing is equal to this variable in my data frame. Now the only thing different about this in any of these other areas is what the heck is going on here. Now the glue package is a package that allows you to use template literals, or I don't know, some other official names for it, dynamic strings, or yeah. So basically, just like C and some of the other low-level languages, I know C, C++, and Rust can all do this. You have the curly braces in here, and I have the name of the name of an existing variable in my data frame. And because R is a vectorized language, what that means is that when I say I'm using a variable title, it's not just a single value, it's an entire vector, not just an array, kind of like an array, but more powerful. So when you do something on a vector, it occurs to every single operation. And just as a quick demo of that, because it is kind of relevant, if I can remember the hotkeys on my Mac, it is kind of relevant. So if I have a vector, I'm going to say test vec. I'm going to assign that a vector done with C, or I think it's just concatenate. I don't remember what it stands for, but 1, 2, 3. So we're going to say that vector test vec is equal to that. So now we can see test vec 1, 2, 3. There we go. So now if I say test vec times 2, it's going to actually do that to the entire vector. Every value has the same operation applied. So because R is a vectorized language, it makes a lot of data manipulation and a lot of things easier to deal on data sets. So how this applies here is that start month is not just a single value, it's a vector. So every time we have a value that occurs for each of these variables inside of this row-wise data frame, basically every row is iterated on by this function. So whatever happens one time happens for every single row here. Now, what this is doing is this is basically saying for this single variable, we're just combining some stuff. So I want to actually add for this current incrementer for the for loop for I equals 1 to 2. So first iteration, second iteration, each iteration combine a string of start month, start year, an arrow, end month, end year, just to make it look nice. And that looks like, if I can, that will look like this. January 2021, an arrow, March 2021. That's what it's doing. It's just combining strings. So that is basically how this is structured for every single one of these project areas. That's it. That is all the complexity there is. Now, the only thing that takes some tweaking is figuring out which of these variables align to which piece of content here, either this heading, the bulleted list, the area, the time frame. These can actually be completely freeform. You can choose to say, make this your date and make this down here a gray where you worked or a red date. You can change these based on what you assign to which of these variables. So you are somewhat limited by the template itself and its structure, but you can sort of twist and bend where things are organized and how they're organized. But these sections are all structured exactly the same, in essence. The only time I've used LaTeX in here at all is this single little command, \page break, because sometimes the content breaks at a really weird place, and I just wanted to cleanly put certifications on its own page. I had it elsewhere one time, but I added some new entries right before this talk, and so I actually had to switch out where that page break was. So you can just add that one line, and you're good. That's all you need. So once we have all this, all I need to do to actually make my CV happen. Let's say I just started a new job. I'm going to add some new entries to work, add some new entries like these two. I just started a new job on March 8th. So there we go. Here's 2 new entries. And now all I have to do is say, yep, that data is valid. And I'm ready to knit. And knit is basically render, compile, run the document. So when I knit, it will open up the R menu here. It's going to compile in the background. And then it will open up a preview window somewhere, or maybe I have that option disabled. It will open up an option, or the file itself, and this is what the rendered document looks like on my local system, which is basically what I just ran. So we saw that I have these 2 new entries here for my current job, Information Technology Associate. Now, if we say we want to actually live preview a lot of the changes we're making, because we don't like how this looks, I want to change something. Let's say I have a really bad design choice and I want to make this red color into something really dark, and I want to remove my current job rows there. I can do that, save it, knit, and now the changes will actually, because this is the document itself, compile live, output file, and now, oh, there we go. So we just updated. Now my current job is gone. All of the colors are now changed to this really dark, moody color there. Let's do something fun. 689D6A. And run. And like this, you can just live tweak this document, see how it compiles and renders, add some new data, and just like that, you're able to completely tweak and update your resume without having to fiddle with something obnoxious and annoying like Microsoft Word, which to me is the biggest benefit because there's nothing more obnoxious and annoying than having to mess with Microsoft Word. So it looks like I have to click on it to actually update it there. But there you go. So now you can change different pieces of this and compile. How does this compile? What is going on here? So in the background, and just a little bit of background and context on RMarkdown, the programming language, is that R is a language written by and for statisticians and is widely used in academia, data science, and in my case, a lot of data analytics and data analyst work, but it's also just incredible for doing documentation production. There's different packages like page down, book down, RMarkdown. There's a variety of packages that facilitate amazing document production, but through the use of code. And even to my knowledge to this day, the best plotting libraries and dashboarding libraries are still done with R. Python can come close in a lot of other areas. Python can scale. Python is multi-threaded. R is kind of getting some work done in multi-threading, but the actual visualization libraries through ggplot and dashboarding through Shiny are simply unmatched in Python. So there's trade-offs to every language. And with R, you can use something like RMarkdown, which is basically like a Jupyter Notebook sort of. You have content and you have cells mixed into each other. So what is this running in the background to compile? It's just pandoc. If you've never heard of pandoc, pan, many, doc, document. So many documents. Pandoc is a tool that renders certain document formats to other document formats. And you can take Markdown and convert it to, I don't even know how many formats that are supported in pandoc right now, but just some simple examples that RStudio supports. You can take RMarkdown documents and convert them to, I don't see the option here, but basically HTML, Word, PowerPoint, PDF. Those are probably the ones that I use most frequently, but there's many, many, many more. You can render RMarkdown through pandoc to so many other formats and other formats to other formats. Basically, pandoc is the Swiss Army knife of document production and compiling to different formats. So that's how we're using all these different technologies. YAML front matter, RMarkdown, and R code, a tiny little bit of LaTeX right here, and in the background, a LaTeX template, which the LaTeX template, if you care to look at the insanity that is LaTeX templates, I will probably never touch one or make one myself. This is the insanity of a LaTeX template. It is a lot of shenanigans, and this is actually a relatively short one. I've seen some that are thousands and thousands of lines long to do formatting. So in the background, a little bit of LaTeX, and that's it. So with this, you can make your own automated, data-driven CV. You add new records and new rows to these tribbles, and you don't even have to approach it this way. This is how I approach it, where I just put everything into a single R file. I use tribbles to source it so I don't have a CSV floating anywhere. This way I also have the ability to debug anything that goes wrong in my data frames when I'm porting them in, because if it's a CSV, you're likely not going to have as much of a robust option of, hey, you're missing a comma there, or something went wrong. So this is just how I chose to do it, but you're not limited to doing it this way. Hell, you could have everything defined in the RMarkdown file and have it all encapsulated under a single file, if you chose to do that. Now, just taking something of mine, you could do that. I have a repo for it for obvious reasons, but attached to this, and I will put a link in, is this CV folder that has basically a copy of everything I showed you today, except it is most of it is, I think, stripped. Or maybe I just put a copy of my entire thing in here. But, oh yeah, so there it is, it's blank data. So like you can see like how the data looks like, so you can map it yourself of like, okay, the names like Certified Lean Six Sigma. So I can see that that will actually, under certifications, where is that area? Where is area going to? So under certifications, wherever, I can't even know my own resume. Certifications, Lean Six Sigma. Okay, so area is this big dark header here. And so that way you can map where things go and set it up yourself. Oh, and I almost forgot. Why am I repeating the same stuff over and over and over again? So the only reason to do that is because all the way down at the end, all of these pieces of data have to be exactly the same to be grouped under these entries. So the first two lines of work for me, before I deleted them there, the first two lines, I have two bullet points, languages used, tool used. I have all this other data here, location, date, the title, and where. All of those things correspond to these actual columns. So all the way across, they are almost entirely identical until I get to the last comma-separated value, which is the detail. So the details are the bullets, and if you want to have multiple bullet items instead of a single bullet, you have to duplicate the entire entry up until that last field. So that's why some of these have several different repeating lines, and they have to be exactly identical, otherwise it thinks you're talking about a different entry. And that is about everything you need to know about this. Once you have the actual RStudio IDE installed, once you run that bootstrapping code on the README, if I can click the right link here. So install RStudio, run this code in the R console to bootstrap yourself with all the packages so you have everything you need. You can use the template repository for this, feed in your data, see where I put things and what that looks like, and now you can compile and have your own data-driven CV. This way, you never need to screw around with Word formatting and getting in the weeds of stuff. You basically just add some new data to a data frame, recompile your document, and you're done. It's never been easier to update your resume and keep it current. And that's all I have for you. So I will open up to Q&A if anybody has any questions or wants to talk about something specific about this.
Well, I think this is pretty interesting. I think I think maybe a question you probably get often is, why create a CV going with this route instead of just doing it through Microsoft Word or like just creating a PDF of some sort.
Yeah. Okay, let me tell you about my my vendetta and my quest against Microsoft Office and Word in particular. I hate that program with the fiery passion of 1,000 suns, and I can give you a litany of reasons why. Namely, it's a nightmare to open, edit, and save documents, and I need to print this. Why is there a weird page break? Why is there an unbreakable space inserted at the bottom of this thing? Why did the file turn into some sort of corrupted binary file or .doc, different formats, and then you can't do simple operations like Markdown, plain text, which means then you have the entire world of everything we do with code. So how ubiquitous is Markdown? You can use it with static site generators. You can use it with note-taking applications. It's plain text, so you can manipulate it and use it on the CLI using command line utilities. It is a more flexible format, but Markdown by itself is plain text. That looks like something you could write in Notepad if you're on Windows. Workdown, what the hell am I saying? Word, in comparison, is a WYSIWYG GUI editor, meaning what you see is what you get, graphical user interface. It looks pretty. It's very end-user friendly. It's kind of like the caveman option. If you don't want to get into code, tech, and figure out and compile things and deal with any sort of other technology other than point, click, select some text, click the bold button, then Word might work for you. It could and can just get the job done. But for those of us who like to experience more automation with tech, don't want to have to go through the effort, or if you're me and want to achieve peak laziness, I don't want to have to screw around with formatting. I don't want to have to have a Microsoft Word or Office license. I don't want to have to pay for it. Granted, there's free options, but I've grown to absolutely hate the file format, and I prefer Word for everything. So those are some of the options. But if you chose to go this way, you have the benefit of scalability, flexibility, but not too much flexibility, because that's another issue with Word, is that you have paralysis of choice. There's way too many options. There's so much going on. There's a million buttons, a million options, a million dialog boxes and menus nested how many levels deep, who knows. Microsoft supports everything going back to prior versions into the abyss of time. They still support file formats decades old. They still have somewhat support for VBA in the background, which was like from the 90s. So our Word comes with a lot of baggage, a lot of headache, and it can get the job done and be simpler. But if you want a cleaner, more robust, more flexible, and less complicated, in a way, form of a CSV, then this is a great way to go. Markdown combined with a little bit of LaTeX polish, but without having to understand the entire sphere and ecosystem that is LaTeX, because that one is, believe me, it's insanely vast.
Yeah, you brought a great point about Microsoft Word being super bloated and somewhat kind of a pain to use to do basic formatting, right? And going this route, if you're so used to like typing code or wherever you're keyboard inclined, then this is just so much more efficient and, and whatnot.
Yeah, let me tell you about my current quest at work. So I just started this new job in March 8th, on March 8th. And at the beginning, we were doing documentation on all of these IT services, our DevOps operations, and we were doing this in Word. Word, in essence, the new versions of Word, Office 365, it's a .docx file. The X format to these, the Microsoft Office files, XLSX, PPTX, DocX, basically indicate that those Microsoft Office files are compressed XML documents. So if you actually ran a command line utility or managed to run a decompression operation on one of those Office files, it would actually be a zip folder with an XML document, maybe some other junk, but an XML document inside. And you could actually look at what actually happens inside of that document. But because now it's XML and not binary, like the .doc file extension of old, that's why Pandoc can actually convert Markdown into Word. And then also you can take Word to PDF, or you can just do Pandocs, use Markdown straight to PDF, because that will use LaTeX. So again, flexibility. But with Word, if you want to have a line-by-line diff, version control, or any sort of automation on your document, you're going to want something to be in plain text, because plain text is diffable. It's version controlled with like Git and GitHub, which you can version control things like Word documents, but you don't have the power of diff. You can't see changes. It's kind of like a snapshot system, not an actual diffable version control. So if you want that granular information about the history and life of your document, you're going to want to go plain text with some version control. And in the end of the day, coders, technology, programmers, what do we deal with? In the end of the day, what is the thing or medium that we're screwing around with? It's text. End of the day, all code is just text. So what are our tools amazing at? Our IDEs, our command lines, these things are amazing for manipulating text. So if what you need to do is deal with plain text and have the power control to change it and manipulate it for your benefit, i.e. making a CV, what better thing to do than use programming and programming's tools? Any other
I
questions?
had one question, just about the part on the kind of the duplicate data. Did you try to see if there's a way to avoid having to duplicate that data in the data frames, or do you know if there is a way to do that?
Um, I haven't looked that closely into it just because this wasn't really a hassle. I use Vim mode, so I'm not typing this all the time. Like, I could easily just do, get out of my face there. So if I have a lot of entries that I want to change, I could easily just do, yank, yank, paste, 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 paste. And now I have a bunch of entries, go to the end of the line. And then I could say from here, inside of the double quotes, change everything in the double quote. Now I have an empty data value. And hell, if I was there, I could easily just say, now I have an empty data point here, yank that one. And now I can fill in lots of extra data. And in that case, that's much easier for me than having to figure out all of the effort of having to go in to figure out how to automate something else. Because there's always that trade-off of, yeah, I could automate just about anything, but is the payoff worth the investment of time? So I kind of decided to not really look for a different way, but there might be. I don't know if there is one.
And then I was wondering, oh, Jeff, did you want to go?
Oh yeah, this is a really quick one. So where in the file do you tweak like the formatting and the layout again?
The formatting and the layout is messed around with via these little sections. So the primary workhorse of this entire operation is the detailed entries function call. This is what creates these aesthetic entries here. And so the assignments of with, what, why, these are the actual input parameters. And the way R works is that also kind of like Python, where you can actually have the name of the parameter and actually declare the name here and say this is equal to this. That way you can also put them out of order. Or you can just do like the actual, I forget the exact technical term, where it knows that the order of placement correlates, but just to be explicit. But this is where the actual work is happening. The detailed function entry input parameters assigned to the columns inside of your data frames.
Interesting. So where do you like this is kind of like my designer side coming out here. So where do you like change like the padding and like and I saw they had some text aligned to the right. So like where in the code do you mess with the layout and the styling?
So that is where you start getting into, where is this tool the best thing for me? Because there's not really an easy way to manipulate that unless you're going to go and write some LaTeX code. This is usually, like this exact approach here is for people who are either one, really familiar with R's ecosystem and R code, and know that LaTeX is really powerful and don't want to do too much tweaking. They want something that looks good, good enough, and can be done. But if you're looking, Mr. Designer, who likely has very specific tastes, you want to have that granular control. Maybe you're a CSS wizard and you want to actually really get into the weeds on every little piece of formatting in here. This might not be the best approach for you because you're going to have to deal with something as esoteric as LaTeX, which is this LaTeX class file. Personally, I haven't touched this. I wouldn't even know where to begin to mess with this, but if you were going to change it, you can actually see some of their comments in here, but you're going to be editing this class file to do anything that manipulates that. But the benefit, if you decided to go through this effort, is that when you deal with LaTeX, LaTeX is like programming, but for typesetting. So you could write completely plain text documents with this LaTeX markup, and then say every time you see a header font command, you can actually change how this command's output is rendered. So if you have something that correlates to a bullet, and then you, at the top of your document, define that function command, bullet or whatever, to be the color red, well, you don't have to change any content in your document, unlike Word. You're going to just say, now color red, and it's going to update in the entire document. So that's the trade-off, is that if you want more granular control, more personalization, this probably isn't something that you want to go with. But for people who want something that looks pretty good for minimal effort, especially like if I was in high school again, going to get my first resume done at the community center, the thing was ugly. So this would be something that would be relatively easy to get off the ground.
Yeah, this is kind of like that plug and play approach where you just plug in data, not worry about like the design and stuff like that. So yeah, I can definitely see benefits of that right there.
Yeah, and with the YAML, like this front matter up here, all the stuff at the top, you really just feed it in which particular pieces of information you want, the image based on a relative file path to wherever it is in this project directory, and then you can have everything that looks exactly like this. But beyond just the actual content, plain text is basically the only thing I've dealt with in this. Beyond the content, all the stylistic stuff here is done by the LaTeX class file. So if you want that granular control, this is probably not something for you unless you know LaTeX or want to.
Yeah. And then one last thing before I'll hand it off to the rest of the people here. So this is just all this stuff is public on your GitHub, right?
Yep, and I will put the link into our Discord as well, to the sample on the talk, as well as my own personal CV if anybody cares to look around at that too.
Awesome. Thanks a lot, Bryan.
Yeah. Javi, do you have a question?
Yeah, mine was kind of related. So the layout's coming from the Latex template. I was just wondering, is there more than one template available, or does it only come with one template?
Yeah, that was actually probably a good point to bring up that I didn't. I'm using the awesome CV template. So R, kind of like C++, some stuff that's similar like that. The double colons here indicating that we're using a function within a namespace. So the Vitae package has its own namespace, and inside this namespace is the awesome CV function, object, whatever. This is only using the awesome CV template. Now with the Vitae package, if I was going to make a new RMarkdown document here, I can say I want a document to go to PDF output, but actually from template. So in template here, I have the ability to see, okay, here's the Vitae package. There's a lot of other templates that are available to me through the Vitae package. So I'm not sure how nice this is going to play with my current content setup, but if I chose something like, let's do modern CV. Actually, let me change this here to, what was that option there? Modern CV format. I'll just have to open a new one. Okay, modern CV. So if I change my content here to modern CV and compile this, it'll look something like that. This is where it being LaTeX comes in handy, is that the content doesn't matter because the controlling of the format in the content is what you're automating. So you can input your content, and obviously this looks a little wonky because I prepped this for the other template, but you can easily change out which of these templates, play around with which one you like best. And yeah, so actually that was actually a really good point I forgot to bring up, is that you're not limited to just the awesome CV class file. So now I have all this stuff right here for moderncv.cls and a bunch of style stuff. This is all LaTeX junk. So if I click that, here's the actual LaTeX template for the modern CV. But yeah, there's a variety in here. And then usually when you install the package, they have a sample that will usually just pop up with, I think, like Mary Curie or something. Let me see here. Which one is it? Modern CV. Yeah, we'll just do this one. Maybe this is it. So here's one, Mary Curie. And so they give you a sample of what Mary Curie's would be like. And you actually have the ability to also automate, like if you're an academic, you can actually automate getting a bibliography file of all of your citations and papers and actually having that pulled from the web and inputted into the document through some other friendly packages. But knitting that, you can see a resume for Mary Curie. This is called untitled, so I'm looking for untitled.pdf here. Somewhere. Come on now. Oh, there we go. Okay, own folder. So here is that with absolutely no changes. This is just like one of those samples they give you to, you can just compile and see where things map out to. But yeah, so these types of resumes, you can just play around with the templates and see what you like. Change a few of the things if you just want something good enough, and let it get out of your way.
That first bullet point is kind of funny.
Yeah.
Oh man.
There's some crazy scientists out there that do some crazy things to themselves when they can't get the approval to do other types of trials. But yeah. Anybody have any other questions before I end the recording? Okay.
Maybe just one more. just when you mention like the vectors and doing operations on like the whole list of data,
Mm-hmm.
I was just wondering, do you also have the option of just doing the operation on one piece or one item in the list, or is it always like you have to affect all the items?
Um, it depends. I mean, isn't that the answer for everything in programming and tech? Is it depends. If you have a, oops, if you have a data frame, or not a data frame, if you have a vector, one, two, three, you can do things like, let's just say, test vec. I'm not sure how well this will play here. Okay, so that will work. The only thing that doesn't work is the fact that it's not a zero-based array index, and I don't like that. But anyways, so with this, we can use this indentation to subset. And that's one of the big things in R, is that because this is meant to be a vectorized language to perform data analysis, data science, data analytics, is that this is really useful for subsetting data. And even without using functions, some of the packages and libraries that really like put this stuff on steroids, is that the base language will allow you to subset things like this. So for instance, with a single bracket, I'm subsetting a single value in a vector. If we were dealing with something like data frames, if I remember correctly, 2 brackets will subset a particular value, where a single bracket will actually subset an entire column. So we can actually look at this. I can say, let's do work, which is a data frame I currently have, and 1. Okay, so that actually subsetted the entire column of title. Now, if I did this, and let's just say I want to subset 1, 2, 3, 3, let's see if this will work. Nope. So sometimes, I'm not too familiar with base R. I'd use mostly something called the tidyverse, but with that, that's letting me get a bunch of stuff. So yeah, I'm not too familiar with base R anymore, but you can subset values, and where with that, you're not doing the operation to an entire vector at once. So in this instance, I can say, yeah, that value 2 in here, and multiply that by 2, and you can do that. But you're not also mutating the data. So this is still 2. So if I did test vec, it's still 2. So you can pull values out of that vector one at a time if you wanted to, and perform some operation. There are functions and packages that are iteratable onto the data. The thing with R is, R has for loops, but they're almost never used. And it's highly advised that you never use traditional looping and iteration on R, because it's vectorized. So there's actually some operations that kind of do like the map, reduce, that type of stuff. Most of those operations with the per package, that stuff is actually the more advised route of doing iteration and repetition over certain things and objects and data frames. Not necessarily normal iterables, but you can, using that method too, do certain operations and then normal traditional control logic. So for every item in this vector, perform operations. If item is equal to a 2, then spit out hello world into the console. Or so you can still do a lot of the traditional approaches of things, but accessing a single value, you can subset and do that with this way, mutate it, and then let's just say I want to reassign this to the value of this vector. Let's test that. So test vec in the space 2 is going to be assigned the value of test vec number 2 times 2. Let's see what this looks like. So you can mutate one at a time. R is a quirky language, so if you like weird things, try R. All right, if there's no further questions, I will end the recording. And thanks for listening to me ramble on about my plain text quest.